Tesla has never been a company to operate according to standards, particularly in electric vehicle innovation. Tesla has consistently pushed the boundaries of what is feasible in an industry dominated by custom and opposed to change. Underlying this disturbance was Tesla's fundamental reassessment of the electric engine. Beyond a part, Tesla's electric powertrain addresses a seismic change in vehicle architecture, providing unparalleled execution, efficacy, and consistent quality. The induction motor was first patented by Nikola Tesla in 1888. To the present, AC motors are a feature of our industrial civilization. Everything from elevators to streetcars, ceiling fans, and washing machines, anything that plugs into the electrical grid and spins is more than likely to use an AC induction motor inside. So when it was time for Elon Musk and the Tesla founders' motors to select a power source for their first electric roadster vehicle, there was really only one evident possibility. The AC induction motor, when utilized in the EV's design, gives you one major advantage that we know. When you rotate the magnets, the stator moves faster than the rotor. Electrify the rotor to produce a magnet. As you spin the rotor quicker, the stator employs an external force, such as a wheel, to electrify the stator, which can then transfer the excess energy back. And that's how regenerative braking works. However, they also came with a key shortcoming that needed to be addressed. So the brilliance of the AC induction motor and its simplicity in its copper coils. Wire multiple pieces of steel and iron into a squirrel cage constructed of aluminum bars. Not much. That's exactly why the motors and appliances such as air conditioners and washing machines can last for decades. Without fail, the downsides of original induction motors continue to manifest. Only when you go in quest of maximum power and efficiency, which is exactly what Tesla was aiming for, did they develop the Model 3. So permanent magnet motors, everything that we just discussed still applies to the new motor that Tesla created for their Model 3, but with one significant addition: permanent magnets. They specifically added permanent magnets. Magnets are linked to the rotor, therefore instead of we have an aluminum squirrel cage. The dense iron core is filled with strip of a magnetic rare earth element known as neodymium, is the technical name for this. The new motor type is IPM, which means internal permanent magnet, synchronous. The reluctance motor is tough. Here's how scoop might be made permanent. Creating a magnet motor using a metal cylinder, applying 4 magnets to the outside with south poles at the bottom and top and north poles on the sides would be your rotor. And then you stick that inside the stator that we discussed about previously and begin spinning magnetic field in the stator. Your permanent magnet rotor coils will slow down the entire system. It's termed back EMF, and the faster the rotor speed, the stronger the back EMF. Combat these two problems we outlined. The design of a reluctance motor, such as aluminum or copper, is only magnetic. When you transmit electricity through them, however, iron has a natural affinity for magnetic field, since we can employ it as a rotor material within our system. Archaic electromagnetic stator and iron. The rotor will move in tune with the rotation of the stator's magnetic field. Again, there is one caveat we must cut. Channels into the iron substance that align with the form of the magnet. The field that surrounds it will align. The magnetic reluctance of iron core with the magnetic field of the stator allow them rotate in sync. Our synchronous reluctance motor is a very efficient motor design, and it works very well at high speed since there is no back EMF generated by the iron rotor. Now all we have to do is add magnets to the rotor, and we will receive a suitable combination of these channels. We cut into the iron core to create the ideal position of our permanent magnets lie, which is our internal permanent place, the magnet within the iron rotor, and we lower the permanent magnets. Effect on the stator windings, and this lowers the problem of back EMF. Before, Tesla motors were never commonly used. Come along, and Tesla is prepared to take this design to the next level. The motor design for the Model 3, Tesla was able to maximize power and efficiency, but it came at a cost. We remember going back to the initial induction motor came with a pretty basic and affordable rotor was produced of aluminum bars. By shifting to IPM, SYN, RM, Tesla introduced the rare earth, integrating neodymium into the rotor. In this situation, the cost is monetary. One of Tesla's most unexpected obligations to the field of electric vehicle development is the consistent pushing of mechanical constraints. The electric motor has been repeated. By combining cutting-edge planning and creative management, Tesla has created electric motors that surpass conventional gas-driven engines and, astonishingly, other electric motors in terms of execution, adaptability, and consistency. This restoration is evidence of Tesla's commitment to advancing B9 to the environmental transportation and increasing EVs to a major and attracting force for customers out of control. Given their best-in-class planning and design, Tesla's electric motors differ from the less standard ones. A basic aspect of this leap ahead is the use of 3-stage 4-post AC and rolling motor in their previous models, such as the Model S and Model X. Trade current, or AC, creates a turning field that drives the rotor of this motor and provides major solid areas for a successful motor. Like the Model 3 and Model Y, Tesla evolved to a very Sintung magnet with a reluctance motor in later versions. By combining the possible improvements in reluctance growth with robust magnets, this motor generates efficiency and power thickness even more. It's quite certain that the electric cars produced by Tesla will run brilliantly. They provide quick power, allowing faster speed increments than several typical factory-regulated cars. Although quick power is well known for electric motors, Tesla has honed it to show up at amazing 0 to 60 mile/hour times, therefore adding to the great show reputation of the vehicles. Moreover, the very strong Tesla motors convert at a greater degree of the battery's electrical energy into mechanical energy. Tesla EVs aid the environment by having more broad driving range and using less energy generally due to their efficiency. Based on their overall programming and motor the Chiefs propels, Tesla's reassessed the electric motor generally by regulating the action of their motors with current-day computations and control systems. Tesla further develops execution capacity and unwavering quality. By means of over-the-air programming refreshes, the company rejuvenates these systems consistently, engaging updates in motor control, viability, and even execution improvements without necessitating actual car acclimatization. Further factors considered in the development of Tesla electric motors are life duration and consistency. External start engines require less maintenance when compared to internal combustion engines, which have many extra moving parts and are prone to mileage since their motors are meant to withstand the challenges of normal driving. Extensive testing and the use of premium materials allow Tesla to create significant solid areas for robustness, extending the presence of its motors. Constant quality is a major selling point because it gives consumers an internal sense of concordance and reduces the overall liability costs over the lifetime of the vehicle. Tesla's reevaluation of the electric motor has had a major influence on the car industry. With new guidelines for execution capability and dependability, Tesla has driven different manufacturers to speed their EV research projects and execute, for all intents and purposes, identical development. The business's increased development resulting from the great pressure has made electric automobiles increasingly widely known and used. Thanks to Tesla's headways, which have in like fashion assisted with cost reduction and the practicality of EVs all around, the EV market has grown. The normal advantages of Tesla's EVs are really high. Electric cars reduce our need for gasoline and lessen ozone-draining material outpouring, improving the environment's viability. Furthermore, the financial advantages, since Tesla's highly viable electric motors require less maintenance and change into more reasonably priced running costs for consumers, are amazing. Apart from that, the choice to support execution and efficiency enhancements by OTA programming, which attracts a lot of consumers, updates the momentum of Tesla vehicles. Re-evaluating the electric motor by Tesla marks a significant change in vehicle development and reflects the company's dedication to reasonability and progress. With its cutting-edge planning, convincing motor control, great immovability, and outstanding execution, Tesla's increased existing assumptions for electric vehicle execution. So what are your views on the present condition of the electric motor? Make sure you share in the comment section below. And if you enjoyed today's video, don't forget to like, share, and subscribe to our channel.